Okay, good evening, everyone. I'm audible, right?
Yes, sir. Yes.
Yes, sir. Good evening, sir.
Good evening, good evening. Today we would be starting the principal stresses and principal strain. Okay.
Okay.
So here I'm not going to derive all expressions. So basically, I will tell I will tell like how it has came, and directly I will write the results, and we will more focus on the solving the problem. Okay. So and if anyone knows the formula, let me know. Huh? I will keep on asking to you also. So first we will take the first case. Okay, simple loading, only 1D stress. Let's suppose. One force P is here, and in a general plane in the anti-clockwise direction. Let's suppose this is the plane anti-clockwise direction theta. So he in this plane, one plane is this. Let's suppose this is A B, and this is O M, and this N. In plane O N, you have to find the normal stress and the shear stress. And let's suppose this is this direction. So this is the sigma N, and this is the tau N. Tau, let's suppose. So can anyone tell? Let's suppose this area of this is A. Okay. So we are defining sigma as P by A. So in terms of sigma, what would be the sigma n? Can anyone tell? Hello. Are you getting what I'm asking? Hello.
P
Hello.
cos
Yeah. Telling. What are you telling?
P cos theta by A
1 minute. P cos theta
by A.
by A. So here you have took the component of force only, right?
No,
Uh,
area
oh,
component.
component of area you have took. So 1 minute. Let's suppose this is the our plane. So i- if this area is A, so this area would be A by cos theta, right? This you have told.
Yes.
Hmm. So, but you have to find the normal stress here. So, for the normal stress, the plane force should also be the perpendicular to this, right? And here force
So,
P,
sir,
P is in this direction, right?
Yes.
So, what would be the force in this direction? That would also be P, or something different. This is theta. Any idea? Just have a guess.
sir, sigma will be P cos square theta by A.
So, what would be this force that I am asking? P cos theta, right?
Yes, sir.
Yes.
Hmm. So normal stress would be the P cos theta by this area. So now it will become P, sorry, in terms of sigma directly I will write sigma cos square theta. Is it clear to everyone?
Yes.
And in the same way tau we can also find. What would be the tau? Now force will become P sin theta, and the area would be the same A by cos theta, right? Hello.
Sir, P by A sin theta cos theta.
So P by A sigma sin theta cos theta means sigma by 2 sin 2 theta. This we can write, right?
Yes.
So this is it is clear to everyone, right? So in this these two are the formula here. 1 minute, let me check whether we have started the recording or not.
हाँ सर शुरू हो गया
किए थे ना?
जी सर
Similarly for 2D stress, this is for 1D stress, and now I will directly write the formula. Okay.
So theta is taken between plane and the normal, or
What are you telling?
so theta is taken from
Theta. One thing, two things you keep in mind here. One is the angle of this theta we have taken from the. Let's suppose this is the x plane. Okay, from x plane anti-clockwise direction. Yeah. Otherwise, anti-clockwise direction you have to take positive. Okay. So one thing you must have remember, like direction of theta, and second thing direction of uh, tau. Tau xy we can say. And that we will see because when tau we will shear stress we will put, that time I will again tell. So that's why I haven't told. So this theta you keep in mind. If anti-clockwise direction you are taking, then you have to take it as positive. Okay. In all formula, whatever we are writing here. Okay.
yes.
Could you please repeat? What?
So what I asked was is whether we take the theta from that plane and
From the this either from y axis you can tell, or this is the, if you are telling about in the terms of plane, then you have to tell it is from the x plane, because this is the x plane, right?
okay, sir.
From x plane or y direction.
Okay.
So when
So
this
what do you mean by that explain? I mean x is a direction.
listen.
Uh,
1 minute. Let's suppose this x, y, and z. So we generally define the plane by its normal. Okay. So if this is the direction, right? X direction, y direction, z direction, right?
okay, sir.
And any plane whose normal is this direction, like this plane one, this plane. So normal to this plane is which direction? X direction, right?
Yes, sir.
So this plane is known as x plane. We name the plane like by this its direction of normal. Okay.
Okay, sir.
So this would be the x plane, either y direction. Okay. So when would be this shear stress would be maximum? Theta would be 45, right?
45
So when this theta would be 45, this shear stress would be maximum. So now coming to the 2D stress system. So there also we similarly take the similarly force with the force balance we can derive the formula, but I am not going to make the force balance and derive the formula. So directly I am writing the result. Anyone can tell. First I will draw, then tell. Okay. Let's suppose this is our direction and this is our plane. Theta, and in this plane here, this is the sigma theta, and tau theta. So can this is we are asking about sigma x, sigma y. So can anyone tell what would be the sigma theta?
sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta.
Here we haven't applied it till now tau, okay, so that will come later. Now what will be the tau theta?
Minus sigma x plus minus of sigma x minus sigma y by 2 sin 2 theta.
Sigma x minus sigma y by 2
Sin 2 theta.
sin 2 theta. Actually, this one thing I want to tell you, this minus will come when this direction of tau would be the opposite of that. So if we are making this element is this way, if you are considering on the deriving formula, theta is this, and if you are considering tau in this direction, then this formula is correct, okay. So here this minus won't come, okay. That's why, because this formula, this will become positive, that's why I have taken in this direction. So so two things you have to keep in mind for the resultant. If you are taking tau xy as positive, so this would be, you have to take in this direction, then this tau will become positive, okay. Otherwise, if you are taking opposite, so you have to take the minus sign, means whatever is there, so you have to keep minus there. In sigma, no difference is there, so this one mistake we might commit. So
Okay.
this one thing keep in mind, okay.
Okay, sir.
So now general formula will write 2D stress and shear stress will also be there. Let's suppose here we will apply this way. So can anyone tell what is the formula for that? Same way. Sorry. What is the sigma theta and tau theta? Hello.
Yes, sir.
Yes.
If anyone knows, can tell. Otherwise, I will start.
Sigma x plus sigma y by 2 plus
One
sigma x minus sigma
sigma x
y by
plus sigma y by 2. Then
plus sigma x minus sigma y by 2 cos 2 theta
sigma x minus sigma y by 2
cos 2 theta
cos 2
और
theta
minus tau xy sin 2
minus
theta.
tau xy.
आपने साइन वो कर दिया है ना सर, उल्टा
1 minute.
टाउ का माइनस साइन टाउ एक्स वाई साइन 2 थीटा.
tau theta और sigma इसको उधर ही रहने देते हैं.
सर अब प्लस का साइन आएगा
प्लस टाउ एक्स वाई
साइन 2 थीटा.
For this
So the first term remains same with the minus sign. Minus sigma x minus sigma y by 2.
you are telling me minus sigma y minus sigma x minus sigma y by 2.
Sir, we'll get a minus also.
Not getting, what are you saying?
It will be minus of sigma x minus sigma y by 2.
No. This would be this way. If you are changing this resultant direction of tau theta, then it will become minus.
सर इसके बाद होगा माइनस टाउ एक्स वाई cos 2 थीटा.
Tau x y cos 2 theta. So this would be the final. This equation we will generally remember, and if anything needed, like if you will put tau x y 0, then this system will become, and if you put sigma y 0 and tau x y 0, then this will become, right. This one. So I am saying like if you change the direction of this tau theta, if you opposite make you opposite to that, then it will become minus of this and plus of this. Okay, opposite to that. So remember any one way and go that way only. And here keep in mind we have taken tau xy this way positive here. So in for questions that may also be changed. It is opposite to that, so that time you have to take that as negative. So 2-3 things sign of that you have to remember, and resultant you have to remember. Here tensile stress we have taken as positive, and the shear stress component of the resultant rotating trying to rotate at clockwise direction, that you have taken positive here, right? So that you keep in mind. So I would say like take the screenshot of this formulas and then we'll proceed. If you are writing, then okay.
I have done, sir. Written.
Okay, so we'll proceed, right?
Okay, sir.
Yes, sir.
So now here again I will write sigma n as sigma x plus sigma y by 2 plus, if I am writing anything wrong, let me know. Okay, y by 2 cos 2 theta plus tau xy sin 2 theta, and here I will write a theta. What is this? Sigma x minus sigma y by 2 sin 2 theta minus tau xy cos 2 theta. So what I am looking for, I am looking for the maximum normal stress at any in which plane this normal stress would be maximum or minimum, and what would be its value. Got it?
Yes, sir.
So if you want to get the maximum minimum of anything, what usually we do?
So differentiate
So differentiate this. What is the variable here?
theta.
Theta is variable. So when we differentiate, this would be the what is this? Constant for that, right? So it will become 0, and here we will, when we do sigma x minus sigma y by 2 right, and minus 2 here, and what is this remaining? If we will take minus 2 of common from all sides, it will become tau theta, right? See, match this.
Yes, sir.
Clear to everyone or not?
Yes, yes. Great.
So what result we have got from here? The normal stress would be the maximum at the at that angle of plane where this uh, this is 0, right? Tau theta is 0. Clear or not?
Sir, clear.
Yes.
So normal stress would be maximum or minimum in those planes where this is 0. So in which plane this is 0? With that plane we will find from here. So make this as 0 and find the angle here from here. Here what will come? Tan 2 theta is equal to 2 tau xy by sigma x minus sigma y, right? What is this? Plane for maximum or minimum normal stress, right? Hello.
Yes, sir. Yes.
So how will you find the value? How much will be the value? Then simply we will what we will do?
Just take tan inverse.
2 theta we will get from here. So
Half tan inverse.
half of tan inverse. But here we have to put the sin theta and cos theta, right? In terms of sin theta and cos theta. Hello.
हाँ सर हाँ सर
So you have the value of tan theta and you have to find the value of sin theta cos theta. You can easily find, right? You can do
Yes,
this
sir.
way. In tan theta, let's suppose you have 2 tau xy this and not 2 tau xy and sigma x minus sigma y by 2 this. And this easily you can find, right? When you know perpendicular and base, hypotenuse you can find. And sin theta cos theta value you can get and put here, right?
sir.
Hmm.
One thing, would it be sigma x minus sigma y by 2 or just sigma y?
Where?
Uh, base.
Why? Do this 0, make tau theta 0 and find the sin to theta from here
Okay,
and
okay,
cos
okay.
theta.
Got it.
This will come, right?
Uh,
So is this till here it is clear to everyone, right?
Yes.
Hmm. So here we will get two planes, right? Two values. Hello.
yes, sir.
This would be the for to theta and theta plus 90. Correct or not?
Yes.
Hmm. So for one plane it would be the maximum and for one plane it would be the minimum. Okay. So those two values directly I am writing here now. 1 minute. So this would be for maximum is sigma 1 and for minimum is sigma 2. So this formula you might be knowing, right? Principal stress value formula. What is that?
So sigma x plus sigma y by 2
Hmm.
plus root over sigma x minus sigma y by 2
Hmm.
the whole square
Hmm.
plus tau xy square.
Hmm. And for the sigma 2 it would be the minus, right?
Yes.
Hmm. Okay. So sigma 1 comma sigma 2. This formula you would be knowing, and we know the value of the tau max. What would be the tau max? How will you find that?
Plus
Maximum.
sigma 1 minus sigma 2 by 2.
How that will come? From here
Maximum will be.
we can find like maximum tau would be the differentiation of that and make that to 0, and then that theta will be put here, right?
Uh,
So
So actually 45 degrees from the principal plane it will be.
that also we can say, but we haven't discussed about that, no? So okay, that thing I will tell here. So this 2D stress, what this 2D stress is showing? This 2D stress is in the normal loading sigma x and sigma y is like what? This is the principal loading, right? No shear stress in that plane. What is the principal plane? Those planes where no shear stress is acting, right? So in this in the 2D loading, it is showing like it is the principal planes, right? Clear to everyone or not?
sir.
Yes.
Hmm. So for the this 2D loading, what is the formula of tau? This, right? This one, correct?
Yes.
So here for the maximum tau, what would be the value of theta? 2 theta would be 90 and theta would be 45, right?
45.
So what it is showing? It is showing like for the maximum shear stress, it would be the from 45 degree from the loading, right?
Hmm.
So keep this one thing in mind. So what would be the plane for the maximum shear stress? It would be the 45 degree from the principal loading plane, right? So a lot of question will come like what would be the now one question is Okay, this we will write first.
So you're saying that pure sigma x, that element is principal plane.
Here no shear stress is there, na? So that's why this.
Okay, sir.
If shear stress is there, then first we have to find the principal plane and principal stress. Then from that direction, from 45 degree would be the maximum shear stress plane. So that would also be asked to you, okay, in the question. So general loading would be given to you, and it would be asked to you like find the normal stress at the plane of the maximum shear stress plane. Okay, that those type of question we'll see later. So what with the tau max? Sigma 1 minus sigma 2 by 2. So this will become sigma x minus sigma y by 2 whole square plus tau xy square. So it is clear to everyone?
Sir.
So it is clear, right? What is principal plane, what is principal stress? Can anyone define both? Hello.
Sir, principal plane is a plane where the normal stress is maximum and the shear stress is zero.
Principal plane, maximum or minimum, anything could be there, right?
Yes, sir, extreme normal stress.
Okay. So that what one thing I am telling to you. Let's suppose one question. One example I will give to you here. So this this is general example I am taking. Okay. So here let's suppose 100 megapascal stress is there, and here it is 50 megapascal. This is 25 megapascal. So quickly, can you tell what would be the sigma x, sigma y? Sorry, sigma 1 and sigma 2. And it's theta p1 and theta p2. What is theta p1, theta p2? Clear, right?
Yes, sir.
Principal plane for both you have to take. One minute take and tell.
So for the previous case, if it is taken as a 2D element, then the tau theta and tau sigma theta is in a line.
No, what I'm saying?
So for the previous case, there is only the 2D element with only sigma.
Okay, okay. Yeah, huh.
We are calculating the sigma theta and tau theta, isn't it? So those are acting on line.
Acting on?
Uh,
One
I
minute.
mean, on that plane there is no shear stress. Then how can we say there is tau theta?
No, no. You are so okay. You are telling about this here. No shear stress is acting. So why we are calculating theta? That you are saying, right?
Yes, sir.
You here stress shear stress is not in this plane, but different from this plane. Shear stress would be there, right? What is here? Here in this plane, shear stress is there, right? Example, you take example.
Yes,
So
sir.
but from here you will calculate the two planes of principal plane where some theta would be there, right? This would be the theta. So this theta would be there, and there would be no shear stress, right? Because this is the principal plane.
Yes, sir.
So there is only two cases where no shear stress is there. Apart from that, everywhere shear stress is there, right? In all planes. What are those two planes? Principal planes. So these are the only principal plane we are telling about here. Apart from that, all planes would be having shear stress, right?
So that shear stress will be acting perpendicular in any other direction to the 2D plane.
What?
Uh, the tau theta will be acting on the plane which is inward to the paper or outward?
No, no, it is. Let me make one series diagram. Okay, let's suppose this is the case. Okay, so this is your principal plane P, huh? And sorry, sigma x and sigma y. Okay, here no shear stress is there. So which type of plane is this? This is plane is like that, right?
Okay, sir.
If this type of plane we are taking, then no shear stress is there. This type of plane or this type of plane. Hmm? If any plane some at some angle, like let's suppose this is the plane, you are able to get what I'm trying here.
Yes, sir.
Let's suppose this plane you have took. Now it is at some angle from the y plane, right?
Yes, sir.
So now there would be some shear stress. Only these two planes, like this, only simply x plane or y plane, those won't be having shear stresses. Apart from that, all plane would be having shear stresses.
Yes, sir. Yes.
So that shear stresses we are finding here. Okay.
Okay.
So can have anyone calculated? Hello.
Uh,
Yeah, yeah. Sigma 1 should come around 100 or 105, 10 like that.
110.36
1
MPa.
minute. 100 point?
110.36.
Okay. And what is the this sigma 2?
39.65 MPa.
39.65. And what is this tau max?
35.35.
And this sigma pa means first angle.
Pi by 8 and 5 pi by 8.
In degree, can you tell?
22.5 degree.
And here plus 90, right? 112.5. So this is clear, right, to everyone? So which one for sigma 1, which angle would be? This, right? Sigma p1.
P1.
And sigma 2 sigma p2 for this. So we will be making one schematic plane for that. Let's suppose this is 22.5 degree. Okay. Hello.
Yes.
It is similar to our convention, right? Here anti-clockwise direction we are going. So in this plane it would be the sigma 1, right? Hello.
Yes.
That I am telling because sometime it might be needed to you, so that's why I am telling. So exactly at 90 degree to this, let's suppose this is the second plane. So in this direction, this is also in positive, so it would be in this way, right? Sigma 2. Till here, any problem to anyone? Hello.
Yes.
So now can anyone tell like in which plane what is sigma 1? 110.36 and it would be the 39.65. So in which plane this would act? Can anyone tell? Hello.
Sir, 22.5 plus 45.
22.5 plus sorry, theta would be 22.5 plus 45. So now just try to see from this way. Let's suppose this is only 45 degree, right? 45 degree. So this would be the plane where maximum shear stress would be working, right? Hello? Hello?
Yes, sir.
Yes, sir.
So maximum shear stress would be here. So this is tau max. Tau m I will write. So my question is how much would be the normal stress here? Got my question?
Yes, sir.
So can anyone tell? Means what is the question? Normal stress at the plane of tau max, right? Hello.
Yes, yes.
So you can think of like what I would tell to you. See this formula. This, right? So now think of only this principal loading. Principal loading, if you think of, then it would be the 2D stress condition, right? Here and here. Let's suppose this is sigma 2 and this is sigma 1. So in terms of sigma 1 and sigma 2, what would be the formula of sigma theta? Anyone? Hello? Is it correct or not?
Yes, sir, it's correct.
At any theta, this would be the sigma theta. So which plane you have been asked for to find this? Which plane you have been asked?
Any angle theta.
Which? For this problem, what would be the theta?
67.
No. For the from sigma 1 and sigma 2, what would the value of theta for the maximum shear plane?
45 degree.
45 degree, na? So theta would be the 45 degree. My question is clear or not? Why you are struggling?
So,
Yes,
sir,
sir.
the sigma x plus sigma y by 2.
Okay, that at the end it will come. First we will see. So here theta we will put 45 here. When theta will put 45, what will come? Only sigma 1 plus sigma 2 by 2, right?
Yes.
So this would be the answer for this. So here sigma 1 we know, sigma 2 we knows, and one thing I want to tell. In this formula, sigma theta we knows, and now can you find sigma plus 90, sigma for theta plus 90?
Ha.
So what will come?
Sigma y dash.
Sigma x plus sigma y by 2, then
Minus
uh,
same term.
right?
Yes, sir.
So if you add the now add sigma theta and sigma theta plus 90, what will come?
sigma x plus sigma y.
Sigma x plus sigma y. What is the significance of this? Can anyone tell?
ये इनवेरिएंट है सर, मतलब स्ट्रेस इनवेरिएंट कहा जाता है।
So stress invariant of what?
वो जो मैट्रिक्स होता है उसमें
No, no,
वो
no.
कैसे?
Listen, listen. So what these two terms are justifying here? This is the stress at any plane theta, right? Normal stress at any plane theta. This term. Hello.
Yes.
Yes,
And
yes sir.
what is
Yes,
this
sir.
term? Normal stress to the complementary plane of this. Why complementary? Because if this is the theta plane at 90 degree, 90 degrees complementary angle, right? So this is the summation of the stresses at two complementary planes, right?
Yes sir.
And what is this sigma x and sigma y? This is sigma x plane, this is sigma, this is also complementary, right?
Yes sir.
So what this is showing? This it here, from here we this is the for the general theta formula, right? At any angle this is valid. So here the summation of the normal stresses at the complementary plane is constant. This you have to tell. Got it?
हाँ
Hello.
सर, हाँ सर, हाँ सर।
Any doubt till here?
No,
So from here what is sigma 1 and sigma 2? Sigma 1 sigma 2 is complementary plane or not?
हाँ, complementary plane.
Right? Because here what we have did, see here, sigma p1 sigma p2 90 degree angle difference, right? So this sigma p1 and sigma p2 are complementary planes. So what this also we can write as, for what we can write, sigma 1
Sigma
plus sigma 2 is equal to
y.
sigma x plus sigma y also, right? By 2.
Yes sir.
This also we can write.
तो वी गेट 75 75।
Yeah, 100 plus 70. 75 ampere. So now what conclusion you have got from here? If you have been asked to find the maximum normal stress at the plane of the maximum shear stress, whatever would be the loading, you need not to see, just simply add the normal term formula and divide by 2, right?
Yes sir.
हाँ सर,
So this one conclusion you keep in mind. Okay. Hello.
हाँ सर, हाँ।
Any doubt till here? Then we go further.
Yes.
Hello.
सर एक बार फिर रिपीट कर दीजिए वो जो लाइन बोला आपने।
If you are able to see these two terms, then it is clear. I am saying, like, if you have to find the normal stress at the plane of maximum shear, then you need not to find the principal stresses first, right?
हाँ सर,
Why need not to find any principal stresses?
So because sum of any two normal stresses which are
So because in the
complementary.
question anyhow they would be giving two normal stresses to you, right? So simply you add both of them and by 2. Okay.
Yes.
हाँ
So now we will take some special cases and then we'll start solving problem. Do anyone know pure shear?
Yes sir.
Twisting we can say, right?
हाँ
Yeah.
Twisting is example for that. If we give torque to this shaft, torque T, so one shear stress would develop to its cross section. So can anyone know what would be the magnitude of that?
T R by T R by J।
16 T by pi d cube, right?
अरे हाँ, मतलब वही टी आर बाई जे ही है।
So here, well, magnitude, if d is the diameter of this, so it would be the 16 T by pi d cube. So here we applied the T torque, and now shear stress we would be knowing tau xy, right? Hello.
Yes sir. Yes sir. Yes sir.
So one element we would have taken. 1 minute. So here what is the loading condition? Can anyone tell? only
only
shear stress, right? So this is tau xy. So what would be the principal plane?
45 degree to it.
Hmm?
45-degree anti-clockwise.
Okay. What would be sigma 1 and sigma 2?
Sir, it will be the same magnitude of shear.
सर
Sigma
एक होगा minus tau xy.
this will come, right?
Yes sir.
Hmm. So now when tau is 0, can anyone tell?
At maximum
Which plane?
principal.
That's why that plane I want to know, na, where is. That's why we are making tau as 0.
45 degree.
So for to know that, we direct simply first we write the formula. What is the formula of tau? Sigma x minus sigma y by 2 sine 2 theta minus tau xy cos 2 theta, right? So this term is not there, so it would be 0. So this will become 0 and cos 2 theta is 0 means theta will be 45, right?
Yes sir.
45 or 135, both we can say, but that will see. So 45 degree from here. So this would be the plane, okay? So let's suppose this is 45 degree. So here would be the sigma 1 and in this plane it would be the sigma 2, right?
Yes sir.
Hmm. So one thing we came to know here, for the pure shear, what is the condition? Sigma 1 plus sigma 2 is what?
0.
0. So this keep in mind, for the pure shear condition, sigma 1 plus sigma 2 is 0. So this is the loading condition, right? So now here two things we came to know, like what is the maximum value of shear stress, that would be the tau xy only, and what would be the sigma 1 sigma 2 tau xy and minus tau xy, and summation of both would be 0. So example of that we know, it is the twisting of shaft, right?
sir.
And now is the next one is the isotropic stress of isotropic state of stress. What is meaning of that? Hello.
Yes, sir.
Isotropic means same at a given point stress would be the same everywhere, huh? So let's suppose this sigma x is also sigma and sigma y is also sigma. Okay. Hello. Hello.
Yes.
Yes, sir. Yes, sir.
So so it is given here. So if this it is like this, then what would be the sigma 1 and sigma 2? Can anyone tell?
So due to isotropic, it both
Hmm?
would be zero, sir, right?
What?
As it as it is isotropic, so sigma one and sigma two both would be same. So sigma one and
What is the value here? That I want to know now.
would be 0, sir.
Why?
Sigma, sigma, sir.
It would be
Ha ha ha
sigma.
ha.
This
Sigma,
also would be
sigma.
sigma, right? Put in the
Ha ha
formula, na. You can see sigma
ha
1
ha.
plus sigma x plus sigma y by 2. That would give sigma, and tau is not here. So that would come 0, and sigma x minus sigma y
Mhm.
by 2 का whole square, that would be 0. So sigma will come, right?
Ha.
सर यहाँ आइसोट्रोपिक शब्द का क्या तात्पर्य है?
So what is meaning of isotropic? First let me know that. Anyone can define what is isotropic?
So stress would be the same at each
Leave
and every
stress. What
point.
is isotropic?
मतलब
Isotropic means at a given point property would be same in the r direction, right?
Ha.
So this is the meaning of isotropic. So here a property is stress now in this case. So at a given point, what this square shows? This square shows a point, right, in the material. So in this point, stress is same everywhere. If this is the meaning of this term, then the stress would be the same, whatever the direction it is. It would be same, right?
Ha, sir.
So these two are the specific directions. So that also would be having the same value, right? So what would be the tau at any plane here? With putting in the formula, let me know,
it will be 0, sir.
right? Because what is the formula for tau? Sigma 1 minus sigma 2 by 2 sine 2 theta, right?
Yes, sir.
That I made in terms of sigma 1 and sigma 2. In terms of sigma x, sigma y, will when you put, then it tau x y term will come. But in terms of sigma 2, sigma 1, sigma 2, it is correct, right?
Yes, sir. Sir, sin 2 theta, हाँ सही है, सही है.
So when sigma 1, sigma 2 is same, tau theta will become 0. Tau theta will become 0 means what? At any angle theta, shear stress would be 0. Means no shear stress at any condition. What does it signifies? Can anyone tell?
सर मतलब जो फ्लूइड में जो होता है ना प्रेशर टाइप, वो तो कंप्रेसर हो गया.
That is different. Here means
Every plane has a principal plane.
every plane is principal plane. This condition is for the making that plane as principal plane, because that plane is having zero shear stress. So here all planes are having zero shear stress, means all planes are principal plane. Okay. Hello.
Yes, sir.
Yes, sir. Yes.
So how many principal planes in this condition? Infinite principal plane would be there, right?
Yes.
So what is the practical example for this condition? Anyone?
कंप्रेशन का तो समझ में आ रहा है, फ्लूइड का जो प्रेशर होता है.
For this condition, what is the example? Okay. So if you take the thin spares, when we will study that time, we can see applied with internal pressure. So this will give tensile stress to its body. So magnitude of that we'll see later. So here example is the thin spare with internal pressure. Okay. Hello.
Yes, sir.
So till here, any doubt to anyone?
No, sir.
Okay. So now we knows the two equations. One is the, let's suppose, sigma theta. What is the sigma theta? Sigma x plus
Sigma
sigma
x
y by
plus
2.
sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta.
And another one?
Sigma x minus sigma y by 2 sin 2 theta minus tau xy cos 2 theta.
So these two equations we are knowing here. So actually what we are going to, 1 minute. Okay. So here what we'll do, we are trying to plot the variation of the stresses with the angle. That is our aim now. So we will modify this equation a bit. So this will make us sigma theta, and this take this term to that side, minus sigma x plus sigma y by 2 whole square, sigma x minus sigma y by 2 cos 2 theta, and plus tau xy sin 2 theta. And make this as equation 1 and make this as equation 2. Okay, now what you do, take the square on both side and add the equation. Sorry, this is this. So what will come? Sigma theta minus sigma x plus sigma y by 2 whole square plus tau xy square is equal to mm, square of this and square of this. Hmm? So this will become sigma x minus sigma y by 2 whole square, right?
हाँ
Hello.
sir.
And square of this and square of this, it will become tau xy whole square, right?
हाँ sir.
And 2 times of this multiply of all this and 2 times of multiply all this, that will get cancelled, because it here a plus b whole square, here a minus b whole square, right? That you can see or not, what I'm telling.
हाँ
So this will come, right? Hello.
हाँ sir.
So make the under root of this and same square of this. So have you able to see anything here, what it became? Here it is like the x minus x naught whole square plus y minus y naught whole square is equal to r square, right?
Hmm.
It is in the form of
More circle. More
it is
circle.
in the form of circle, right?
हाँ.
With the
More
center,
circle.
sigma x plus sigma y by 2 comma 0, and radius as this
R square.
this would be the center, and radius would be here this under root
Hmm.
sigma x minus sigma y by 2 whole square plus tau xy square. What is this? Tau max,
हाँ.
right?
हाँ.
So now we are able to draw a circle. Here it would be the tau and here it would be the sigma. So what is the center? The center, this point is y axis would always be 0, and this point is sigma x plus sigma y by 2, right?
हाँ.
Okay, so till here everyone it is clear? Hello.
हाँ sir. हाँ sir.
Okay. So I will ask you quickly. You tell me how the more circle of that will be made. Hmm? If sigma 1 comma sigma 2 both positive, how it will be done now?
Circle having its center on the right hand side and whole portion right hand side.
This way, right? In this figure I will tell everything. This will show sigma 2, and this point is showing sigma 1,
Sigma.
and what is this? Tau max. Hmm?
Hmm.
Okay. So anything else here left? Okay. So this point would be the sigma 1 and this point would be the sigma 2. Now second case is both having same value and in the negative. Sigma 1 comma sigma 2 is less than 0, not equal to. How it would be? It would be this way, right? Which one would be the sigma 1 and which one would be the sigma 2? That tell now.
So sigma 1 would be the like
This.
yes sir. This one would be the sigma 1.
Option
Where is
A,
your
option
pointer?
B.
Option A would be the sigma 1.
Okay. How many saying
And
like A would be the sigma 1 and how many say B would be the sigma 1?
B would be sigma 1.
So A only.
Some are saying A, some are saying B. Here you have to see like sigma 1 means more value. More not more magnitude, okay? So B would be the sigma 1. That keep in mind. It is sigma 1 and it is sigma 2. Okay. So now this is first case, this is second. Third case is like sigma 2 and sigma 1. Got the case? Hello.
yes.
How
Yes sir.
how the Mohr circle would look like?
It would be on the right side. The circle would be on right side.
Whole circle.
Huh.
So this would be the first one.
Some will be right, some will be left.
It would be like this, right?
Huh.
It would be sigma 2, it would be sigma 1. Can anyone tell my one question is there? What is the condition of pure shear? Hello.
Sigma 1 plus sigma 2 0.
Sigma 1 plus sigma 2 would be 0.
Sir, I have a doubt here.
Center will be
1 minute.
origin.
What are you telling? What doubt?
Sir, actually, usually if they ask what is the maximum sigma, then we'll say A only, no, sir.
What is the maximum sigma then?
It will be A or B, sir. It will be A only, no, sir.
Okay, in this case you are telling, right?
Yes, sir.
So no, if they are telling about like major principal stress or minor, which one, what way they are asking, huh? If they are asking about this, and then you have to tell about this. Hello.
Yes, sir. But if they ask what is the maximum normal stress, it will be A only, no, sir.
That maximum normal stress, if a magnitude directly they are asking what would be the maximum magnitude of the normal stress, then obviously you have to tell about A only.
So because the maximum depends on only the magnitude, no, sir, because it doesn't depend on the sign.
Actually, they if they are about asking about directly magnitude only they are asking, then you have to tell A. Otherwise, if simply maximum they are telling, then means they are asking about the major stress, major principal stress. Okay, got my point or not?
Yes, sir.
If magnitude simply they are asking, then magnitude you have to take. Okay.
Yes, sir.
So my one point here is normal stress when would be 0 generally? Normal stress 0 or not? Tell me this one thing.
No sir. Here normal stress. How could it be 0, sir?
Why?
And in this diagram.
At this point, zero.
It will be
Here point A, point B. Normal stress is 0, right?
yes.
So for the pure shear, what would be the Mohr circle? This way, right?
More circle would be like every diameter would be the like same like uh, quadrant for the quadrant.
This would be the Mohr circle for the pure shear, right?
Huh.
Then why we are not saying this is the pure shear? Why this is not pure shear? Pure shear.
Sir, now I got it. So because sir, there on some point normal stress would be the zero. So therefore, uh,
What are you telling?
uh, in like for the upper portion, like on sine quadrant, like it would be 0 tau xy and like
Not
that.
getting what are saying. Here also here also only 2 points are there where shear
Huh,
stress is 0, right?
huh.
Here also only 2 points are there. Here also 2 points where shear stress is 0. Sorry, normal stress is 0. And normal stress 0.
But those points are not the maximum shear stress points in
It will
case of.
not satisfy the condition which you explained. Invariant is 0.
Which invariant? Okay. You are telling about sigma 1 plus sigma 2 is not 0 here. That you are telling. Huh?
Yes.
Okay. So you are saying here it is not pure shear because sigma 1 plus sigma 2 is not 0, right?
Yes.
And here sigma 1 plus sigma 2 is 0.
Yes.
Let's suppose you don't know this. Like condition for pure shear is sigma 1 plus sigma 2 would be 0. Why this condition is there? Because you know like twisting of shaft is the pure shear condition. Huh? So from there you got this condition. Let's suppose you don't know that condition, then how it is been came? In twisting of shaft, what in pure shear condition what happens? In the shear, change in the dimension is not happening, right? Hello. If you
Sir,
are
how dimension don't be
uh,
changed, sir, if
see.
there is
If
no
you are
pure
applying
shear?
shear stress to this block, what will happen?
Huh,
It will change its
the-
shape, not dimension.
huh.
Hmm. So
But
in shearing, what happens? Shape changes and volume not changes.
hmm, hmm,
So volumetric strain would be what? 0.
0. Huh.
And what is the volumetric strain? Anyone knows the formula?
Epsilon x plus epsilon y plus epsilon z.
Okay, that is there. But when we add all those, then it will become sigma x, sigma y plus sigma z and 1 minus 2 mu. Or anything is also there.
Y e.
It is right. It is correct. I think so. By E, this is remaining. It is correct, right?
Huh.
How it came that you know or not?
So it would be better if you could elaborate it a little bit.
Let's suppose this is the cube and here sigma x, sigma y and sigma z. Huh? So
Hmm.
what would be the sigma epsilon x? Sigma x by E minus mu times sigma y by E minus mu times sigma z by E. Same way epsilon y we can write, same way epsilon z we can write and then add it. Okay?
Huh.
Then it will come. Hello.
Got it, sir. Got it.
It is clear to everyone, right? Hello.
Yes, sir. For me, it's clear. No, sir.
So
Sir.
listen. So what happened in the pure shear condition? It should be 0. So how it can be 0? It can be 0 in two ways. One is the either this term would be 0 or this term would be 0. How this term would be 0? When mu is equal to 0.5. And when this would be 0? Sum of all normal stresses would be 0.
0.
And in the twisting of shaft, what happens generally? Third direction stress don't come, so sum of two principal stresses is 0. From here it has came. Okay. So for the pure shear condition, what would be the condition? The sum of normal stresses should be 0, but it is not happening here. Normal stresses sum is not 0. Some of you have told this, but reason is this. Okay.
Okay.
Is it clear to everyone or not?
So can you kindly repeat it?
In order to make the volumetric strain 0, what is the formula? This is the formula, right? So how can this be 0? Either mu is equal to 0.5, mu is equal to 0.5 for the plastic material, perfectly plastic material. Okay. Either that you can take that and there any loading you can make, that would be the pure shear, because here volumetric strain is 0. So or this loading condition is such that sigma x, sigma y plus sigma z should be 0.
Correct.
So but in pure shear condition, third direction stress is not coming, 2D stress develops there, so z terms not coming, so sigma x plus sigma y or sigma 1 plus sigma 2 is 0. That is coming by loading that we have seen. So that's why we have said like it is pure shear like that. So
Yes.
same way here it is not happening, because sigma 1 plus sigma 2 is not 0. It is coming here. It is not 0, right? Because it is asymmetric from here. So some volumetric strain would be there. Some volumetric strain is there. That's why it is not pure shear. Okay.
Yes.
Now clear or not?
Yes.
Okay, then anything remaining or not?
Sir, for these cases, surface shear strain associated with axial circumference direction, right, sir?
What are you saying?
For surface shear strain in this case, for more circle,
For which case?
in principal shear stress.
Actually, I am not getting what are you saying. Repeat it again.
Actually, I'm asking that for principal shear stress, the surface shear strain associated with axial circumferential direction, right, sir?
Not able to get which direction, which stress you are saying.
For
Which case
for
exactly? Tell which case. This case
no fourth.
for pure shear.
Pure shear.
Pure shear. Then
Okay. I'm asking that for pure shear, the surface shear strain would be on the basis of
which
axial
surface shear
surface.
strain? How strain now come to picture?
There might be, won't there be?
Okay. You are asking, generally asking about strain. Okay. Then
On the would it be associated with the axial circumferential direction, like the way the we will represent the stress?
not getting it. You are asking about with strain what you want to associate? Stress.
Huh?
Okay.
Surface shear
Okay.
strain.
You are telling like if there is a pure shear and strain you know, from there you want to know stress, right? That is the next part. We'll see.
Okay.
From strain how you can get stress. That is the next. Maybe today we were not able to finish that, because before that strain, all strain part we have to finish. Okay. So till here I think it is clear to everyone. So now one more case we will take and then we'll solve the question and finish for today. So now coming to the, let's suppose for the pressure for the let's suppose this is the water tank and here some part is there. So this point is under water pressure, right? So what would be the shape of the More circle for that.
Sir, could you please repeat
Point.
it once?
Point any compressive stress point in inside the water. What will be the Mohr circle for that?
It will be point.
It will be point where in this is origin, left or right, negative or positive side.
It's
Negative.
negative.
Or
This is for the compressive water particle, any water molecule in the here. And now fifth point would be isotropic state of stress. What would be the Mohr circle for that?
So on the right side, it will be a point.
Right.
This would also be point, but here, right?
Yes.
This we can say also like hydrostatic state of stress. Huh? Hydrostatic state of stress. Okay. Yeah. Have you been able to see this question?
Yes, sir.
See this. Take 2 minute time and try to solve. Mostly calculator won't be needed for that. But if you are having, then it's good.
Sir, option A is
Okay. 3 sigma, right?
हाँ sir.
Okay. Any other answer? One is 3 sigma. Okay, so anyone more people are trying, or we should start?
we can start.
Okay. A circular shaft is subjected to a combined here combined loading is there, a combined action of bending, twisting, and direct axial loading. The maximum bending stress is sigma. So what is the let's suppose this is the our real shaft. It is first it is applied to twisting, and now bending also. Let's suppose this is bending moment time, and next is compressive. This three loading is there. So now coming to maximum bending stress is sigma. So can anyone tell like how bending stress varies?
Linear.
It will vary linearly, and if nothing is mentioned, then assume it is symmetrical. Okay. So this would be the sigma. It will vary from tensile to compressive, right? So this would be the sigma of P. And now coming to the maximum shear stress. How shear stress will vary? Across the cross section, it will also vary in the same way. Here, here in opposite direction downside is this point, and this point would be the opposite to that. So this will become also go this way. This is how much? Root 3 sigma. And the this is the sigma. Sorry, this is the tau. And the now coming to the compressive stress. Compressive stress across the cross section would be the same, right?
Hmm.
So this would be the sigma. Now can anyone tell which stresses are the normal stresses and which are the shear stresses? These two are normal, right? Bending stress is normal stress. So we have to go for the maximum compressive stress. So here we will take this and this, right? Hello.
Yes, sir.
So maximum compressive stress would be the sigma C max would be 2 sigma. It is clear or not? Because here if you will see the
Clear,
combined
sir.
effect, so upside it would be the in the normal stress across the cross section, how would be the variation? Here it is 1 sigma, here is 1 sigma, here tensile, here compressive. So total variation would be this way, right? Here compressive. This would be the normal stress variation across the cross section. This would be the 2 sigma. So and now normal compressive stress is 2 sigma, and this shear stress is 3 sigma. So resultant stress how will you find? Now here it is in the one direction, so you can think of it as sigma x. Sigma x is what? 2 sigma minus of 2 sigma, we can say.
Minus of 2 sigma.
And sigma y what we can write? 0, right?
0.
And what would be the tau?
Tau would be the root 3 sigma.
Root 3 sigma. Simply principal stress sigma 1 and sigma 2 we can find, right? What is sigma 1 and sigma 2 you have found? Formula you know, right? Formula is what? What is the sigma 1 comma 2? Sigma x plus sigma y by 2
by 2
plus minus
root of
sigma x minus sigma y
by
2
2
whole
plus,
square plus tau xy square.
plus tau xy square.
So what it would be?
Minus 2 sigma by
This
2
would be
minus
minus sigma plus minus
plus of root 3 sigma whole
would
square.
be the sigma and 3 sorry sigma square and
3 sigma root 3 sigma square.
right? So this will become either sigma or
Either 3 sigma
minus 3 sigma.
minus 1.
So this you have to keep in mind. Here they have asked about the maximum compressive stress. So maximum compressive stress would be what? 3 sigma, right?
3 sigma.
Is it okay to everyone? Hello.
Sir.
Should I go forward or should I wait?
No.
See this problem and quickly respond in 1 minute.
$50.
Okay. Any other answer? Any other people? One has said 50 and other? It is easy problem, right?
Okay.
Sir, since they asked resultant, we'll consider them as vectors. Sir.
Yeah. That one thing also I want to tell. Mm, Generally, we consider moment of inertia stress strain as the second order tensor, right? But while adding two types of stresses, we can consider as the first order tensor, right? Like vectors, okay? That you keep in mind.
Yes, sir, 50. Sir.
Okay, so we'll see. A piece of material is subjected to the two perpendicular stresses of 70 and 60. So this is 70 and this is 60, sorry, 10. The magnitude of the resultant stress on a plane in which the maximum shear stress occurs. Which plane maximum shear stress will occur? At the 45-degree, right? So that we know, and the maximum, what would be the maximum tau max? This is the sigma 1 and sigma 2, right? No shear stress is there. If that would also be there, then we can easily find the sigma 1, sigma 2 and then find the maximum shear stress, and then the we know the what will be the value of the sigma at the tau max plane, right? What is the value of this? Sigma 1 plus sigma 2 by 2, right? Or sigma x plus
40.
sigma y by 2, that we can also see. It would be the 40 ampere.
Normal stress would be 40 and shear stress would be 30.
Shear stress would be the sigma 1 minus sigma 2 by 2. So this will be the
30.
60 by 2. It will become 30 ampere. And the we have to tell the resultant stress. Resultant stress means this is the shear, this is the normal.
Root of
So root of
30 square plus 40 square.
root of sigma square plus tau xy square, tau max square. So it would be 30, 40 means 50.
Sir,
Mm-hmm.
one thing, could you please write down? You told about the tensor when we should contemplate about
Generally,
vector and
stress, strain, and moment of inertia. What are they? Second order tensor.
second order tensor.
Second order tensor. Second order tensor means what? Magnitude plus direction plus plane of action.
Plane of x.
Three things we need to know. But while adding, we can consider
As vector. Okay, sir.
stress as first order tensor. Yeah, Okay.
Okay. Thank you, sir.
So now quickly see this problem. Have you been able to get what has been asked in the problem? Hello. Am I audible or not?
Yes.
The change in plane means the change in angle means change in. Are they asking that in which
Currently, what is the
quadrant?
angle between OD and OC?
45 degree.
Not 45, 90 degree. The angle between OD and OC 90, right? Because it is 45 from corresponding X and Y direction.
Okay, sir.
So just try to see what has been asked in the problem.
Then it is in tension as it would been. It has been stretched.
So it is the 1 by 1 meter and 1 mm thick mild steel plate is stretched in its own. Sorry, it is plane, not plane. Plane. By stresses sigma x 20 MPa. It is sigma x and it is sigma y. 30 MPa. Shown in figure at point O is the center of plate. It is the center of the plate. OC and OD are two perpendicular lines inclined at 45 degree to X and Y axis. Before the application of stress, before it is the condition before the application of stress, find the change in the angle between OC and OD after the application of stress. So what is this direction? It is 45 degree to here, right? And so this is the principal no shear stress is in this plane, so it is the principal plane, correct? So from this direction it is the plane of pure shear, right? Plane of shear stress, not pure. It is the plane of maximum shear, right? 45 degree to this. And here also 45 degree to this, right? Means OC and OD is the plane of the maximum shear.
Maximum shear, sir.
It is correct or not?
Correct. Because both are on 45 degrees.
So what would be the maximum stress? First tell that. Because in that plane you have to find the here change in angle. How change in angle will come? For example,
It will be due to shear stress.
this is only due to shear stress. this will happen, this will happen, and this is the change in angle. How you find this angle? Huh? Anyone? If angle is small, then simply we can make that as tau. Otherwise, we can make a 10 tau if it is more. But for the our materials, we can rightly write as tau. It would the shear stress by G,
G.
right? Stress by
Pulang
strain.
no.
Sorry,
Uh-huh.
is, tau by phi would be the G, right? So G we will come in take this here and tau by G. G it is already been given. So first by the question it is not written which plane is this, that you have to think of, like it is the principal stresses. So from there 45 degree it would be the plane of the maximum shear, right? So what would be the maximum shear stress? Sigma 1 minus sigma 2 by 2.
5 megapascal.
It is 5 megapascal. This is the key point here. Apart from that it is one line question. This you have to think. So this line is clear to everyone or not? After that is nothing. Just simply divide 5 by 80,000. Whatever will come, it will be the answer. Okay. Unit would be the radian. Simply you can convert that to angle, right? 180 by pi you will do and get the angle. It is clear or not? Question is not tough, right?
Yes.
You have to see the concept, like how the things are happening. Okay, then we switch to next problem. See this problem and just try to see. This is also one line problem. Just you have to think like how to solve.
So dimension of that is it 95
For what?
slope?
Here you are telling
No, sir. The next question.
this
Yes.
dimension of block is what
Of
are you telling?
slope, of slope, sir, which you have showed.
Okay, this you are telling. It is 15 by 8. Sorry. It is 15, okay.
Here the grain means this parallel lines, sir.
Okay, this is grain. Okay, this is the direction of grain. This. Means you can consider this as composite material. You know, right? What is composite material? Composite material is one is the, let's suppose this is in composite. Here you can think of this is a whole matrix, and this is one anything you have inserted in it. So in this direction you have been given a stress value of the permissible stress. Okay, so same way here this is the direction. First of all, what is the cross section area? Can anyone have anyone calculated? Hello. Just see wisely, okay?
So it will be 75 into 12 point.
Huh?
It will be 75 into 12.5.
75 into 12.5, right? Or and have anyone calculated like 200 into 12.5? How many of you did my first option? Can raise hand. One minute. Only by first method only one people have done, right? Hmm? Hello.
Yes, sir.
Okay. This is the length of the block. If you see the cross section, make the profile of that. Now it might be clear maybe. This is 200. This is 12.5 and this is 75. So what would be the cross section now?
75 into 12.5.
So this would be the correct. Okay.
Yes.
Okay. So how much this? Hello.
Doing 937.5.
Okay. So first of all, this angle. How much this angle? First of all,
This would be 45,
this would be
45
positive or
degree.
negative? Tell this first.
This would be positive, sir.
Why?
Negative.
It is clockwise, right? This is the y axis or x plane. Here, in order to make that plane, which direction we have gone? Clockwise direction. So negative, right?
Oh, it was clockwise.
So here, very small mistakes, but those mistakes will like blunders. Okay. So what would be the tan theta here?
Hmm.
8 by 15, right?
Hmm.
So how much angle it is?
Because tan inverse 0.
28.1 degree.
28.1 degree. It would be minus, right? Keep this in mind. So now you know the angle and max. Here two things have been given. One is the permissible shear stress parallel to grains. Means here tau max, tau theta they have given. How much it is? 10. And it is in the megapascal. Okay. So if we put, let's suppose here this would be the P by A. P by A, force we will be putting in Newton and this is in the mm square. So resultant would be in the megapascal already. Okay. So we would be writing P as same as P and this would be how much? 937.5 and this would be the What is the formula? Sine to theta, right?
Yes.
Hmm. So theta we knows. Here P would be negative, right? Because it is compression.
सर बाय टू भी तो होगा,
Huh?
साइन टू थीटा बाय टू होगा ना,
Why?
क्योंकि पी बाय टू ए वो था ना साइन टू थीटा, पी बाय टू ए साइन टू थीटा था ना सर.
Which one you are telling?
No, in the formula it was sigma x minus sigma y by 2 sine 2 theta. No, sir.
Okay, okay. Here you are telling. Huh?
हाँ सर, हाँ सर, हाँ यही
Okay.
है.
Sorry, sorry. So here it would be negative, and here theta you put as it, and let me know the value of P from here.
टू पॉइंट फाइव सिक्स थ्री किलो न्यूटन.
कितना कितना?
22.563.
Okay. Now coming to the normal stress. Anyone, if getting other, let me know. Okay. So now coming to the normal stress. Maximum permissible normal stress is 17.25, and same way here it is compressive. This is, so already we can put minus sign here, and same minus sign P by here it would be the P by A, right? 937.5 and cos square theta. So what would be the value of P from here? Hello.
Yes, sir. Doing, sir. Doing.
52.257.
P would be
52.257. नहीं सर, सॉरी सर, सॉरी. $20.78.
any other have calculated this? Hello.
Sir, so here we are considering the uniaxial stress condition. So initially, which we took.
What?
Here we have directly took the condition of uniaxial loading, sir. Like the first case which we took.
Yeah. Here it is given only uniaxial loading is there in the problem itself only.
Yes, sir. Yes. So, but if we remember the overall formula, it is enough, no, sir.
What?
But if we remember the general formula,
That is also okay, na. So simply put there sigma y as 0 and tau xy as 0. This will come on. Just there you keep two things in mind. One is the angle from which direction you are taking. If anti-clockwise from the normal, then you have to positive. Here we are taking clockwise, so it is negative. There is one thing you keep in mind. Another, that shear stress direction you keep in mind, and here stress is compressive, so that you have to take in negative sign. These three things you have to keep in mind by using the formula. Okay. Any formula you use, answer would be same. Okay.
yes.
So have anyone calculated this or not?
Same answer, sir.
Okay. So here with the shear stress, maximum loading condition would be the 22.56 kilonewton, and with the normal it would be the this. So which force you can apply maximum? Which force would be?
22.56.
Why?
20 वाला sir.
If you apply 22.56, then with the in normal condition, normal force, it would peel off, right? Normal compressive load would be more, and it will got broken, right or not?
Yes, sir. Yes, sir.
So it normal force more is the more than the permissible, so it will got broken or not. So it will
হ্যাঁ
got broken, then it is of no use. So we have to choose the minimum of this. So this would be the correct answer. Okay, clear or not?
Yes, sir.
Okay, see this problem and then we'll finish off. Take 2 minute time and then we'll start. Okay. What would be the shape? That let me know first.
Sir, oval type कुछ.
It would be if
Ellipse.
circle is this, then when you apply load in this direction and this direction, this will try to stretch in this will try to stretch in the direction. Direction is not defined, but it will become something like this, right? Maybe it is in this direction, or maybe it is in this direction. Direction is not known. So it would be somewhat of ellipse, right? So in ellipse, you have to find the major and minor axis. So what is sigma x
600
and tau x?
minus 1200
What is sigma x?
minus 600
What is sigma y?
minus 1200 और minus 400 नीचे आ गया.
Okay, okay. This is not in this direction. Otherwise, it will not become ellipse. Take this in take this in this direction.
वैसे भी इलिप्स बन ही जाएगा क्योंकि वो ज्यादा कंप्रेशन है ना 1200.
एक एक्सिस वन एक्सिस शुड एक्सपेंड ना.
ओके सर, तो मतलब यहाँ पर ये जो प्रिंसिपल एक्सिस होगा उसके अलोंग कितना स्ट्रेस है उसके हिसाब से करना है.
That's why one direction should expand and one should compress. Then only it will become. So that's why both are compressed at that time. So this we can take as kilogram per centimeter square. And tau xy plus or minus.
minus 400
minus
According to our formula, this direction you have to keep in mind. Okay. Per centimeter square. So two things you have to tell me first. One is the what is the value of sigma 1 and what is the value of sigma 2, and second thing, what is the angle sigma p1 sorry theta p1 and theta p2. Calculate that and let me know. First tell this, okay? These two things. Tan 2 theta p equal to 2 tau xy by sigma x minus sigma y means what is this? How much is this one?
सिग्मा 1 1284 आ रहा है.
No, no. First, tell. Let me know sigma, theta p1. What is theta p1? Okay, sigma 1 how much?
सर 1284.9.
Okay. Sigma 2?
minus 684.88.
Okay, now sigma p1 and sigma p2. Sigma p1 is 10 to theta p is equal to 4 by 9. Calculate this one.
ट्वेल्व डिग्री आ रहा है थीटा P1.
Exact told you.
11.98.
And theta p2 would be 101.98.
90 डिग्री प्लस.
Right? Means this would be 11.98 degree and this would be 101.98 degree. Now one thing is which axis is means this principal axis is the major principal axis or minor? How will you decide?
जो टेंशन में होगा वो होगा प्रिंसिपल मेजर और जो कंप्रेशन में होगा वो
How will
माइनर
you
होगा.
find that? Now you have two options and two sigma values. Now which will belong to this stress will belong to this one or this one? How will you decide?
सर पहला वाला मेजर के लिए होगा, दूसरा वाला माइनर.
कैसे?
क्वांटिटी.
How will you just try to put in the formula? Okay, what is the formula for sigma at any theta?
सिग्मा 1
No, sigma x plus sigma y by 2
प्लस सिग्मा x माइनस सिग्मा y बाय 2
hmm,
टू थीटा.
hmm, right,
यस सर.
or minus here. Okay, so put now theta this and all sigma x, sigma y, tau x, y values and what is the sigma theta, that let me know.
So instead, we can directly use principal stress formulas.
What?
Instead of using a general formula, we can use a principal stress formulas. Sigma x plus sigma y by 2 plus minus root of.
So from where how you can find like which angle is belonging to major axis or minor axis? Major principal means uh, here we are having two that two stresses we have calculated from there only na, these two.
सर सर मैं ये पूछना चाह रहा था, जिसकी क्वांटिटी ज्यादा होगी वही तो मेजर होगा, जिसका मैग्नीट्यूड ज्यादा होगा.
In this angle you are saying like sigma 1 belong to sigma p1.
यस सर, यस सर.
How will you say?
तो मतलब हमें ये पता करना है कि कौन सा. ओके सर.
In which direction this major axis is, major principal stress is there and in which direction minor is there, that you have to confirm. For that you can only get from this equation, right?
Okay, sir. Okay, sir.
You just simply put what is the sigma x, you know, sigma y, you know, tau xy, you know, and the theta we know from here now. Because these two theta are from the either this would be major axis theta or minor axis theta. Either anything would be there. So one will check and then we'll decide. Got my thing or not?
Yes, sir. Yes, sir. Now got it.
For theta P1, sigma theta will be minus 684.
684, how much? Same, it would be same, right?
Yes.
It should be same because this is our mine kg per centimeter square. So for this, how much theta? Theta P1 is equal to
11.
11.98. So means mm, so what is the conclusion? Like this is for the 1 minute. This angle is for this and this angle is for this, right? Hello.
Yes.
Now circle is initially this, right? Now what would be the shape of circle? Hmm?
मतलब कि एक्स डायरेक्ट ये एक्यूट एंगल बन रहा होगा सर, मेजर एक्सिस। नहीं नहीं नहीं,
Let's suppose this is the direction. So
ऑब्ट्यूज एंगल बन रहा होगा मेजर एक्सिस का, एक्स एक्सिस से।
just let me know either would be this way or
हाँ,
this way.
यही यही जो पहले बनाया था सर।
First,
First one, right?
यस सर।
Because this and so now you have to find the what would be the dimension. Now got the problem. Now we have decided like which would be the shape. Hello.
यस सर, यस सर। नाउ
If you try to make here and do this way. It may not be exactly same, but try to see. So this would be the how much angle?
11.98।
11.98. Okay. So what is your the problem? You have to find this. This would be d plus something extra. That something extra you have to find delta d. Let's suppose delta d1 is it is d1 and 1 minute. Hmm. And second one is this one. That is d minus delta d2. So next any suggestion how we can get?
सर एप्सिलॉन 1 इक्वल टू सिग्मा 1 माइनस म्यू सिग्मा 2 बटे ई, ये इस वाले फॉर्मूले से करेंगे ना।
Hmm. So epsilon one would be delta d1 by d, right?
यस सर।
So find the delta d1 from here and let me know. and same way strain along epsilon 2 direction. What would be this? Delta d2 by d equal to sigma 2 by minus mu sigma 1 by e. So from here delta d2, let me know the value of delta d1 and delta d2. Yes, sir.
सर डेल्टा डी वन 0.07 mm आ रहा है.
Just
ज्यादा ही कम,
confirm this. What is delta d2?
ज्यादा ही कम नहीं है ऐसे.
Is correct. Maybe I think. What is delta d2?
Sir, delta D1 0 point.
0 point.
No, sir. Nothing, sir.
डेल्टा डी टू आ रहा है 0.05, 0.0497 आ रहा है. 0.05 लिख लेते हैं. 497
Plus or minus?
माइनस का आ रहा है सर.
Just confirm the value once, one or two people more, and
मतलब आपने वहां पर डी माइनस डेल्टा डी टू लिख रखा है इसलिए पॉजिटिव बोला था.
here only delta d2 we are writing. No?
आपने डायग्राम में
In
डी
not
माइनस.
in diagram. Here it is delta d2. No?
ओके.
Sir, same answer, sir.
Okay then. It is correct.